Think about the financial transaction data that your bank stores about you, or healthcare records, or even mobility data from your telco provider. But this data is all highly sensitive personal data. So for most organizations, it's locked away and they can't necessarily use it. And this is where AI-generated privacy-preserving synthetic data comes in, which helps you to create a synthetic replica of your existing data that's both privacy safe and way more useful than all the legacy anonymization approaches that were in use, like masking, obfuscation, etc. The competition is running until the first week of July, so our listeners can still jump in and participate. What did we try to achieve with that competition? Some of our listeners might remember the Netflix prize, which was launched 20 years ago and created big waves in the entire community. They back then had a 1 million prize pot. We have 100K, so not yet the size of Netflix nonetheless.
Welcome to ODSC's AIx Podcast, your gateway to the latest in AI and data science. Whether you're an aspiring data scientist or a seasoned AI professional, we bring you insights from the best minds in the field, shaping the future of AI. This episode is sponsored by ODSC West, the premier AI Builders Conference celebrating its 10th year this October 28th to 30th in San Francisco and virtually. Learn more at odsc.com/California and use the code PODCAST for an exclusive 10% discount. We are also holding another virtual 3-week conference, the Agentic AI Summit, this July 15th to 30th. Learn more at summit.ai. Sheamus McGovern, the founder of ODSC, will be your host today.
Welcome to this episode where we're exploring one of the most powerful and often underused tools in the AI toolbox, synthetic data. From enabling privacy-preserving AI to improving fairness, performance, and access, synthetic data is reshaping how organizations build better AI. Joining us today is Alexandra Ebert, Chief AI and Data Officer at Mostly AI, a global leader in structured synthetic data. Alexandra is not only a trusted advisor to the OECD and the UK Financial Conduct Authority, but she's also leading a $100,000 global open source competition to advance synthetic data innovation through the Mostly AI Prize, which is open to all, including you, our listener. So I'm quite excited about that. And if you're curious about how synthetic data is actually built and evaluated, or looking for a hands-on way to deepen your understanding, we encourage you to explore the Mostly AI Prize. And this episode offers practical insights and can serve as a great jumping off ground. So let's get into it. Alexandra, welcome to the podcast.
Thank you for having me. Looking forward to being here.
Alexandra, we met about a month ago at ODSC East. You gave a track keynote there. You gave a great panel session, and delighted to be speaking to you again.
Thank you for having me.
Today's conversation is one I've been looking forward to for quite a while because synthetic data has been around for a long time. It's bubbled up to the surface, especially in the last couple of years. I really believe that synthetic data has become one of the most powerful tools in the AI and machine learning toolbox. But I also believe that too few practitioners are truly taking advantage of it. And we're lucky to have someone here who's helping us shape the way we can think about that topic. Alexandra, can you briefly introduce yourself and maybe some pivotal moments in your career?
I'm Alexandra Ebert. I'm Mostly AI's Chief AI and Data Democratization Officer. Mostly AI is a leader in structured synthetic data. And besides that, I have many different hats. I'm advising organizations like the OECD on AI, data, and privacy topics, so trust in generative AI and how to tackle mis and disinformation. I'm leading the IEEE Global Expert Group on synthetic data privacy, advising the UK Financial Conduct Authority, and many others. If you look at my CV, you're potentially going to wonder what the heck is going on here. So I once was featured on a podcast and they even dug out one of my first roles, which was a horse portrait photographer. Disclaimer, I was 14 years old.
That's cool.
Absolutely. So that was one of the first jobs I did. Later on, I was fundraising for an organization similar to the Red Cross. I was a food blogger and food scientist. Before then, I ended up in the AI space. The red thread, as you would say in German, or a golden thread in English, is that I've always loved to learn. With all of these different professions, I obtained new skills that I now can utilize in my current job. So I think that was one of the core concepts of my career, and why specifically AI, privacy, ethical AI. I've always been fascinated by technology, but not necessarily the intricacies of the technology itself, but how it's going to impact the business world and society at large. And what more exciting space to be in than AI nowadays.
So given all those esteemed institutions you're advising, who better to help us understand what synthetic data is in 2025? Could you briefly explain what synthetic data is and why it's becoming, as you mentioned, such a transformative asset in AI and machine learning?
Sure, happy to. Synthetic data still has a bit of an identity crisis. If I talk with some people, they know the type of synthetic data which already existed 15, 20 years ago, which was overly simplistic mock data. Then some other people think about all the new images, videos, etc., that the ChatGPTs of the world can spit out, or even creating data out of thin air. The type of synthetic data I'm talking about is always privacy preserving AI generated synthetic data. So why do you need that? Particularly when we think about privacy laws like the GDPR in Europe, the CCPA in California, and in other parts where you see similar laws emerging already existing. There is this big challenge that large organizations face. They have a lot of data. Think about the financial transaction data that your bank stores about you, or healthcare records, or even mobility data from your telco provider. But this data is all highly sensitive personal data. So for most organizations, it's locked away and they can't use it. And this is where AI-generated privacy-preserving synthetic data comes in, which is nothing else than anonymization technology that helps you to create a synthetic replica of your existing data that's both privacy safe and way more useful than all the legacy anonymization approaches that were in use, like masking, obfuscation, etc.
Yeah, I think that's so important because that's what we often call the data access paradox. A lot of organizations, like you mentioned, sit on their most valuable data because it's so sensitive, and then they can't utilize it to the degree they will want to because of various laws.
Absolutely. And particularly in financial services, I've heard of data scientists leaving after a few months because they were hired, paid a generous salary, but 6 months in, they haven't seen any data, or just like Swiss cheese type legacy anonymized data, which is no fun to work with. So big issue to be solved.
Can you speak to some of the other core advantages of synthetic data compared to real world data in practice, and maybe then address some of the limitations?
Absolutely. So I think it needs to be both compared with real world data and with legacy anonymized data, because depending on the maturity of an organization, you either see them still using production data in a way that's not necessarily compliant with the laws, or they try to comply with the laws and use legacy anonymized data, which has two big issues. First, we have decades of research showing, regardless of how much data you delete with these legacy anonymization approaches, which are all destructive in nature, basically thinking of a tabular data asset, financial transaction data, something like that, where you go over with a black pen and try to delete how much you spend at the Starbucks, or maybe distorting it to say, okay, it's $5 to $15 and not the $7.50 it actually costs you to have a Grande Venti or however these drinks are called. We know that regardless of how much data you delete, even if you have 2 or 3 attributes that are still real world data, one study showed for credit card data that they could re-identify 80% of individuals by 3 transactions alone, where nothing more than the date and the merchant was revealed. Now, when you think about the dozens or hundreds of transactions that you produce over the course of a year, if not thousands, there's not much data that can be retained. So we have this Swiss cheese data utility problem with legacy anonymization, and quite severely the re-identification risk. Compared to legacy anonymization, synthetic data gives you both really strong privacy protection and phenomenal data utility. Just to give an image for our readers, it's like retaining 99% of information and just eliminating the personal secrets or the extreme outliers. So if my fictitious bank had Bill Gates as a customer, he might be too unique with his account balance and his spending behavior to be able to properly anonymize it. But you can still be very granular with synthetic data, which is a key advantage for many downstream use cases. And that's particularly for machine learning, where we need some of the highest data quality requirements out there.
Yeah. Do you mind, Alexandra, talking a little to how it actually does privacy preserving and break that link between data and real individuals or privacy data while maintaining those statistical patterns? Yeah.
Sure. No, key question here. And this is also the reason why I initiated the IEEE Global Expert Group on Synthetic Data Privacy, which brought together regulators, practitioners, users of synthetic data, and privacy researchers. When we think about how synthetic data is created, this type of synthetic data, they're existing but highly sensitive data assets. You have a generative AI model that helps you, of course, with the representativeness, the realisticness of the data, which can basically understand how the structure of the data set looks, how your customers act and behave, what patterns you have there, what correlations. This gives you the quality of the data. The privacy is brought in by several different mechanisms, and there is not yet one standard how to go about it. But what is very important is, for example, that you protect the value range of your data set, that you make sure that outliers and rare categories are protected. To give you a practical example, if I had a data set of professions and I would find a profession in my original data that says the Pope, I have a pretty good chance when I find a synthetic data set with the Pope that I had the Pope in my original data set. I need to make sure that categories that only appear one time or very seldomly don't land in the synthetic data set to protect the people who have a rare disease, a rare job title, etc. So that's, for example, one mechanism. Another way privacy is protected is by the functioning of the model. It's basically learning the distributions and randomly sampling according to the distribution. And the model compared with this privacy mechanism works like an empirical form of differential privacy. All these different privacy methods try to achieve that you get the exact same outcome regardless of whether I was in the training data set or not, which is one of the key ideas of differential privacy, that an analysis doesn't change, or at least you can measure how it would change if Alexandra or any other individual was in the data set or not.
Yeah, Alexandra, there's a couple of resources I can add to the show notes, because when I was researching this podcast and looking at how you guys do it over there, I learned a lot myself. I also came across some, what do they call it? Risk measured generation or privacy risk assessments. You can run that on the synthetic generated data. And getting back to what I said at the very start of this podcast, synthetic data has been around for quite a while, but I think it's undervalued to a certain degree, because you see mindset in most organizations and data sciences that real world data is the gold standard, right? Which of course it is. But if we think about it as practitioners, we also complain about data. It's messy, it's unorganized, it's hard to access, like you said, tightly restricted.
I would actually disagree with its statement that real data is the gold standard. We know that real data has flaws, and we need to make sure that it is useful and viable for the type of task we want to do with it. But there's so many things that are wrong with real world data, which oftentimes also come down to this question of how did we collect it in the first place? Which questions, which decisions were made in collecting this type of data? So I think this is something that many of our listeners are well aware of handling data. My second reason why I disagree with data being the gold standard is the limited access to data. In most organizations, I work with some of the world's largest financial services organizations, telco providers, insurances, a tiny fraction of privileged people, or as the chief data and AI officer of Lloyds Bank calls it, the high priests of data science, and sometimes just some data owners who can really access this data. Most people within an organization and beyond the borders of the organization never get to see this data. And when we think about all these important considerations of how to treat data, particularly towards fairness, inclusion, etc., it's so important that we democratize this access to data and have a more inclusive group. This is something you can never do with real world data simply because of the sensitivity and people rightfully not wanting to have millions of people snooping around in their actual Starbucks transaction and spending behavior.
Yeah, I think it's good that you called me out on that gold standard for data, because that's a debate we can have all day. But I push back, because whenever I pitch it to some venture partners, a synthetic data startup, what I get pushback on is a lack of real world complexity and missing nuances with synthetic data, which I think is a bit of an unfair criticism, because whatever data you're collecting at a point in time, it too can lack real world complexity.
Absolutely.
Because you're talking about finance, a space I know from having worked in it, and event-driven finance used to be one of my favorite trading methods. Like you look at the financial crisis, that came about because a lot of firms were modeling on data on a housing market that hadn't experienced some of the shocks that they experienced there. So yeah, if we just want to touch upon some of those criticisms of synthetic data before we get into generating it.
Absolutely. So particularly when we want to simulate the world with synthetic data, which is a field that's quite active. Of course, it's no crystal ball and can't predict the future. If there were never a COVID pandemic prior to 2020, how should the AI know? This is a valid concern for this type of synthetic data, which is not necessarily the same type of synthetic data I explained earlier. There you already have the existing world data. The problem is the sensitivity of it, the privacy and the personal data points, which restrict you from using it for AI training, product development, startup collaborations, or putting it in the cloud to access the resources there. Of course, synthetic data and AI in general is not a crystal ball and can help you predict the future. The type of criticism you pointed out applies more to another type of synthetic data used to simulate scenarios. My type of synthetic data doesn't necessarily suffer from that issue because you already have the existing data set. You want to create a privacy safe replica off. So it's much easier to assess the synthetic data quality in comparison to the real world healthcare data set, financial services data set, whatever you have, to have a confidence that you will get on par and same results if you do your analysis or machine learning modeling on the synthetic data instead of the real data. But of course, synthetic data comes with its limitations. The most important ones to share with the audience are, first, it's a big data anonymization procedure. In some healthcare applications, for example, where you have the 20 rarest cancers of the world and only 10 patients, synthetic data or no other anonymization technology out there can help you to really anonymize these data assets without losing all the value in there. A second limitation is it's a privacy protection technology. It helps you to dissect the personal privacy sensitive secrets of the statistical, generalizable, but yet very granular information. It does not protect your business secrets. So if you have a synthetic data set that's statistically representative and you would openly share that, competitors could potentially see who your most profitable customer segment is or learn something else about your proprietary business data. Important to keep in mind also that it's not a two-way street. Once it's synthetic, you can't go back to the real data, which puts a limit to some applications. For example, when organizations want to collaborate with a third party to figure out in financial services what your credit score is, and then really know, is it my credit score or synthetic individuals? So this is also something to keep in mind.
Yeah, those are very valid points. Can we talk a little bit about the types of synthetic data? Because you just mentioned simulation. I guess that's top of mind for me because some of the work I'm doing at the moment is more around physical AI and simulating that real world, which you correctly addressed, that has its own set of challenges. If we can touch upon the different types of synthetic data.
Absolutely. To give our audience an overview of what flavors of synthetic data exist, there is AI-generated privacy-preserving synthetic data as an anonymization tool. You have existing but super sensitive data. You want to have a replica of that data that's privacy-preserving. Then another one that is seeing a lot of traction is using synthetic data generation to create data out of thin air with way less seed examples plus additional knowledge. For example, your knowledge of physics. My favorite example here, self-driving cars. We want to make sure that they're really safe and they don't run over a rabbit or a kid or whatever they encounter on the street, regardless of how said rabbit or kid looks like, from which angle it enters the street, what the weather conditions are, etc. Now, if you want to make sure that your car is adhering to that and always jumps on the brakes, how to create the training data? You could go to a video production company and say, please, I need millions of hours of rabbits running on the street, but I want to do it at nighttime and with a blizzard and a mountain on top and with a unicorn kissing itself in the mountain. It should work in all these scenarios. It should have seen that. Of course, we know that's impossible. It would be way too expensive to create this in the real world, but we don't need to do that because we have a good understanding of physics, so we can pair our understanding of how do light conditions, how do shadows change when it's this time of the day, when the sun is coming from there, when we have a reflection from this mirror, etc. How would it look if it's raining? And pair that with a small data sample of videos of rabbits running on the street to say, okay, and now I want to have the most extreme and complete 360-degree rabbit coming from here, rabbit coming from left, rabbit coming from top, and create all of those samples. Works really nicely, but of course I can't apply that to domains where I don't have that much knowledge to inject to. Think about medicine. Up until the mid-90s, it wasn't required that women were equally included in studies. So a lot of the medical data we have holds true for the male body, but not for the female body. I can't press the button on my generator and say, please now give me the heart attack symptoms for women if I have never studied them. So these are, to me, the two most exciting areas of synthetic data. And our listeners, of course, will be familiar with synthetic images, deepfakes, or funny birthday cards that you can get when you use the current tooling to create something that either looks realistic or completely creative and not something you would encounter in the real world, but where you don't aim to get the representativeness that you want to have in the first two examples. And simulations was, of course, the fourth one that you earlier mentioned.
Yeah, that's excellent because it's something, as I mentioned earlier, I'm looking at for another project, how that synthetic data is generated for autonomous machines. And it's really pretty interesting how they're building these virtual worlds. I think NVIDIA is very involved in that.
Absolutely, with their twin world.
Yeah, the digital twin world. And we were looking at their various scenarios like a child on a bicycle in heavy rain, wearing dark clothing, How would a model do with that? Even introducing random noise into the data set to see how these models can deal with that. And then, of course, a lot of that is to do with introducing these edge cases, which is very interesting. So there's so much work to be done there with synthetic data. But at the same time, there's a bit of a misnomer that it's easy to generate synthetic data, right?
Absolutely. And by now we also see these different worlds of synthetic data marrying, because due to the power of generative AI with the initial type that I described, which is created based on large but sensitive training data set, you can to a certain degree improve that data during the generation to make it better than the real world data for your downstream use case. What do I mean with that? Think about creating a data set that is fair and doesn't repeat the systemic biases or discrimination that we still have in human world and our data collection, or upsampling fraud cases, adjusting the temperature when I generate a data set to make sure that I either get more outliers, which could be helpful for testing purposes, or if I want to distort some of my proprietary business information, or very conservative generation to make sure I have a data set that really adheres to the business rules that it implicitly learned from the original. Or smart imputation. Many of our listeners will know the pain of getting an incomplete data set and having to figure out what they should fill into the different columns. We've had some initial tests on that and some customers playing around with it, but also super curious to get feedback from our listeners. Synthetic data was shown to better impute missing values because it could put the knowledge from the overall distribution in the decision of which value should go in this missing field, depending on all the other characteristics I have with this specific record.
Yeah, and that's actually a great topic to jump to next, because as we were talking about, filling in those missing values is key. A lot of naive methods might be taking the mean, the median, but I think what you're addressing here is that synthetic imputation can preserve that nuance. So in that context of imputations for missing values, do you see people using synthetic data to fill in missing values, not just to generate new data, but to fill in missing data, where that's a large issue?
So it's a feature that we don't have for the longest time now. We only have earlier results, but some customers were very happy about that functionality, given the pain that they have. And also with some tests that we designed where we, of course, had a complete data set and then just randomly made holes into the data set, we could see that it was way better than standard approaches to imputing data sets. A key benefit, as pointed out earlier, is understanding the overall population and the rich understanding of the deeper correlations in a data set, which help during this imputation process to make smarter decisions than just going for the mean value for a specific record. Our human knowledge and understanding of the world helps us to better assess, would it be more likely that a pregnant person is male or female? I have a really clear opinion about that. What would be that age of the person, potentially not going to be an 80-year-old granny who is pregnant, etc. So many of these things can be taken into account. And particularly when thinking about incomplete data sets, there's also the sampling bias question, or this understanding of, is there a specific customer cohort? Many of our customers experience this problem that for some type of analysis and machine learning, they can only use the fraction of their customer database who actually gave explicit consent. And is there a specific demographic, a specific cohort of customers who never ever gives consent? So if you would just fill up this missing 10 or 20% of customers with the distribution you already have consent from, you would get skewed results. For example, I don't know, the academics earning above 200K don't want to be included or something like that. So that's also an area where I got some early feedback from customers that it's interesting how it can help them to fill in some blanks. But of course, early stages and not a magic bullet to know anything we never collected in the first place.
Just to peel back that discussion a little bit, because you touched on two key points there. One is understanding the physical world. I think it's going to be very interesting because obviously a criticism of LLMs and using LLMs for generating synthetic data and other types of simulation is LLMs don't understand the physical world, but I think there's been big strides made in that. So that's definitely a space to watch. Secondly, what you just mentioned about the demographics of certain data sets where people never give content. So you end up with these imbalanced data sets. And I know something that you guys look a lot is this fairness within data sets. If you can speak a little bit to that.
What we thought about 5 years ago was, hey, with generative AI and forcing the generator to create something that's as close to the real data as possible, but privacy safe, what if you would additionally force it to adhere to a mathematical fairness definition? And my colleague Paul Thiewald and former colleague Daniel Sukup looked into this around 2020 and figured out, okay, it's well possible to, for statistical parity, put two constraints into the generation process and then have a data set where you get way better fairness in it as opposed to brute, not force, but more less sophisticated methods where you, for example, would just upsample an existing minority class and say, okay, adult census data set was the one we used for a paper from 2020, which you can potentially link in the show notes. With the adult census data set, we know that there is a heavy imbalance between high-earning females and high-earning males. We looked into that and forced the model due to this additional fairness constraint to actually rebalance that. If you would just upsample more high-earning females to create the same ratios, you would completely skew all your other distributions that you might want to leave intact depending on your downstream use case. For example, who is a high-earning female, doctor, lawyer, some of the high-paying professions, and in general, a woman that's much older. So your age distribution would be skewed, your distribution of professions would be skewed, and of course, many other things down the line. With forcing the synthetic data generator to optimize both for an accuracy loss and a fairness loss, you can achieve minimal distortion from your other distributions while breaking up your desired correlations, like, for example, gender and income. And that's a quite interesting proposal that some of our customers also started working with. But I also want to mention it's not a silver for fairness. Fairness is a tremendously complex problem. So every listener dealing with something that's sensitive and where fairness is a consideration needs to keep in mind it can help to tackle fairness on the data level, but you really need to think about it from the very beginning of your project through the life cycle of your model development to make sure that you do your best here. And of course, it's still an evolving field and a nascent research field. So I hope much more robust things will come down the line.
I think it's such an important part of the field for our audience to understand, because upsampling, as you mentioned, basically increases the number of examples to make a more balanced data set. I think you've given some good examples there. And I do see upsampling being used a lot. I was just at a conference in Bentley University here in Boston, where I think it was Victor Lowe from Fidelity gave a talk about this. And I think that the use case is like if 0.1% of your transactions are fraudulent, your model be trained to predict that most transactions are not fraudulent, which is true. But how
Sure. Does
how do
help you to detect fraud.
Exactly. So I really think, as you mentioned, healthcare, finance, anywhere where you need rare events. So upsampling and using synthetic data to produce that, I think that's good because it helps people ensure that they're not missing any blind spots. The key thing there, which you also talked about, is how can organizations collaborate with other banks or organizations like banking organizations to pool and share this data so they can produce better synthetic data to look for those rare events?
Absolutely happy to touch upon that because it's such an exciting area of data collaboration and data democratization, given that frauds and tackling it is such a strong motivator, recognizing that it costs most financial services institutions many billions per year. How synthetic data is already helping and is going to help the financial services industries and other industries plagued by fraud. One thing with upsampling is, yes, there are cases where boosting your minority class, your fraudulent examples, really can help with the predictive performance of your fraud detection model. More interestingly, is also this balance that financial institutions have to strike in terms of modeling choice. Because even though they might have a very nicely performing model, if it's a sophisticated architecture and doesn't have the best explainability, they might be reluctant to use it for auditing, compliance, and legal requirement purposes. Upsampling the fraudulent class in your synthetic training sample can allow you to have a much simpler model architecture, which then gives you on-par results as compared to more powerful, sophisticated, but non-explainable architecture. So that's where we see the biggest jump on synthetic data for upsampling, not necessarily because of all the gains it can give you, but because of the facilitation of more explainable architecture. The second point, which we discussed earlier, is this notion of if you as a bank have fraudulent examples, luckily it's just a very small percentage, oftentimes 0.01 or 4%. But any other financial service institution is also experiencing fraud. Players in the ecosystem, for example, the network providers, the Swifts of the world, the MasterCards, the credit card firms, etc., are seeing a different lens of the fraudulent landscape. So what if you all were to collaborate and share your lens of the landscape to have a more holistic picture of the different fraud types to better be able to predict and counteract them? And these are the discussions that we're currently leading also with financial services regulators who are really interested in mitigating fraud and the adverse effects it has on the entire ecosystem, where synthetic data going to play a critical role, because with the granularity of data that needs to be shared, privacy, of course, is a tremendous issue. And this is where synthetic data can come in and can democratize these data assets to have in the future fraud models that are way better than only having your own trained fraud model for your own lens of the world.
Those are very important points, Alexandra, and that's great insight. So maybe going back to the generation question a little bit, because we're all used to using various large language models now, and one of the key parameters there is temperature of control. Can you talk about what does temperature mean in the context of synthetic data and how it actually affects the data generated?
Yeah, sure. So particularly in the context of how we do it. So we use an autoregressive architecture, which we also published a paper about, which you can link in the show notes. It's about how the samples are drawn from the distribution that was learned of the training data set and where from the distribution you're basically sampling. So if you want to go more towards the edges or even beyond the edges to create something that wasn't even seen in the training data sample, or if you're conservative and only give the average Jane and John Does of synthetic customers to make sure that certain things like business rules are adhered to.
Very cool. I want to get into something very exciting, the Mostly AI Prize, which is really going to give our listeners a chance to actually listen to a lot of the great advice you're giving here. But before that, I didn't talk a little bit about agentic AI because it's a very hot topic. The agentic AI workflows are getting very complicated very quickly. Of course, I'm sure our audience is very familiar with agentic AI, but what's got everyone very excited about agentic AI at the moment, you have these protocols like A2A from Google, MCP from Epic, released last November. They're getting a lot of traction because essentially it's a standardized way of letting agents access data services. So of course, everyone's talking about evaluating these tools because if I'm going to trust my agentic AI to go into production, I want to have it evaluated. So any advice you can give to folks thinking about agentic AI workflows and where does synthetic data fit into this agentic AI workflow?
Absolutely. So I'm going to take a step back because when I have the chance to speak with the CXOs of the banks, telcos, etc., we work with, this big umbrella topic that they are concerned about is really data and AI democratization, which encompasses the agents, which encompasses AI assistants, but more importantly, also this idea how to go from these high priests of data science or this privileged small group of people who ever get to see some proprietary business data to empowering every employee with access to data. And synthetic data helps with unlocking proprietary business data assets to make them available to employees. But when we pair it with AI assistants and AI agents, it puts the magic together because you then have something that's not only trained on a generic World Wide Web data, but your marketing sales folks can actually ask questions about your customers and relevant business topics. And thanks to the advancements we've seen, particularly with AI assistants, get impactful answers without having to rely on overburdened data analytics and data science resources. To your specific question on AI agents, what I see a lot in my collaboration, particularly with AWS, but also other hyperscalers, is that now everybody's thinking about how to prepare not only for one specific prototype or project, but an entire ecosystem of AI agents. One of the main concerns or challenges is privacy, security, and data access, particularly when we think about how data lives within most organizations. It's not this one unified view of data that they have, but they have some of the data still living in legacy applications in the mainframe. Some data is at a third party. And these access rights across this infrastructure are complicated to merge in one cohesive layer. Some of our partners are actually now working with their customers on creating this synthetic data layer fabric in there where they pull in all the relevant data that they need without having to wait the 3 years of migrating the entire application to the cloud, and having an access control that gives their governance folks peace of mind that the data here is something that the agents can access without being at risk of exposing actual customer information. When we think about workflows where we want to act on customers, synthetic data's role will be in setting up and making sure that all of these different agents and the tools that they can access work together as intended, because as I pointed out earlier, synthetic data is a one-way street, so we can't have an agent act on the synthetic data and just close the credit card of synthetic Maximilian instead of your actual credit card, because that wouldn't be very satisfactory for you if somebody pickpocketed your credit card.
I would certainly hope not. And
Fingers crossed.
Exactly. But I got to say, that's such a key point, because I've been having those same conversations about agentic AI with a lot of stakeholders in industry. They say the same thing. Access control is so key, and it's becoming a real bottleneck in these agentic AI workflows.
Absolutely.
Just to be sensitive to time here, I'm really excited to talk about something that you announced at ODSC East. What you guys are doing over there, mostly AI, is really helping advance the field of synthetic data and AI in general. You've announced a global competition focused on high quality and privacy preserving synthetic data. So let's talk about that initiative and what it aims to achieve.
Absolutely. So it was a real pleasure to have the opportunity to talk about this at the ODSC East conference just a month ago. The competition is running until the first week of July, so our listeners can still jump in and participate. What did we try to achieve with that competition? Some of our listeners might remember the Netflix prize, which was launched 20 years ago and created big waves in the entire community. They back then had a 1 million prize pot. We have 100K, so not yet the size of Netflix. Nonetheless, it has been exciting to see how many people from different parts of the world already participated in the challenge. There are two objectives for this challenge. One is to put a spotlight on synthetic data and encourage and invite more developers and creative minds to focus on this exciting new field. Even though it's such an influential technology, it doesn't yet get the spotlight it deserves. The second point is data democratization and open data sharing. When we think about most of the competitions we have online, it's the same Kaggle data sets over and over again. Being able to globally or collaboratively work on real-world challenges would require open data to be shared. And to protect privacy, if we think about data assets in the financial services industry, healthcare records, so many exciting application areas there, it needs to be open synthetic data, and hope to get more organizations and public sector institutions who are at the brink of sharing open synthetic data sets to make this bold step and say, okay, we don't only want to have AI innovation that comes from the for-profit largest organizations of the world. We want to have open data assets as a resource for SMEs, for startups, for public sector organizations, for researchers and NGOs, because only then, I'm a strict believer, we will see this potential of AI for good being reaped. Because if I'm a for-profit company owning super relevant healthcare data for cancer, they might invent the next treatment for cancer that costs a lot of money and keeps my patients alive 40 years longer so that I have continued profits, but I don't have an incentive to cure cancer. If we were to share this type of data in an open data setting, then I'm positive that we will see this AI for societal good innovation finally going to start at scale. This is another big mission that we have at Mostly AI, and which we hope this prize is going to contribute.
Yeah, Alexandra, that's a great description of the Mostly AI competition. I would really encourage our listeners to get involved, because a lot of our audience, they're seasoned practitioners. We also have beginners. We have some people in the business side. So regardless of your role, check out the competition. I think it's very approachable. Maybe, Alexandra, if we can talk a little bit about the evaluation criteria, because I think the evaluation criteria will be familiar to some people. It might be new to other people, but I think it's also a great learning opportunity for our audience and community. So if you can speak to the evaluation criteria, because I was looking at it myself yesterday and I have some notes in it, but I think that'd be cool.
If you want to participate, definitely go for it. But yeah, fully agree. So both the seasoned practitioners, but even a new person new to the world of data and data science. One of my colleagues recently made a short video with our own Mostly AI assistant. So it literally takes you like 30 seconds to make your first submission, have it submitted. The idea of the challenge is to create synthetic data that falls in a category we've discussed. It should be as accurate to the training sample as possible, but it needs to be privacy preserving. And the leaderboards we have there actually also scores your data so that you can see in real time how good you're doing and whether you want to use one of your remaining submissions to iterate, tweak, and improve. On privacy, since we're short on time, happy to explain how this is assessed, but we can find more details on the website and also in the Mostly AI documentation. One of the ways how synthetic data privacy is assessed in an empirical manner is by comparing distance measures. And you, from a conceptual point of view, aim to get a synthetic data sample that behaves in comparison to your real training sample. So basically, You don't want to have an exact replica or copy of your existing training data set. That wouldn't be privacy preserving, but you want to be as close as possible. And this is the big question. How close can your synthetic data points be before they are privacy violating? Now, there is not a fixed measure that you can aim for because this obviously depends on the data set. If I have a low dimensional data set where I only have the zip code, gender, and the job title, I expect to have a synthetic sample where I find the same distribution of teachers living in the financial district in New York are female and 23 years old or something like that. It's not a high dimensional data set. If I have a data set with 500 columns, I'm quite likely not wanting to have a direct match because that would quite likely be a privacy violation. You need a benchmark to compare it to. This is what the holdout data set from the original data allows you to do, because then you can see how many teachers in the 23rd district did I have in my holdout sample, how many do I have in my synthetic sample, and is this closer than the holdout, or is it too close to the real data, or is it as close as the holdout? And then from a privacy perspective, assuming that this data is safe. So very layman explanation, all of the details, how this is calculated, etc., can of course be read up on the website and our documentation. This is not only a synthetic data competition, but it's really an open source, open innovation, open data competition. Later on, the top 5 leaders of each of the 2 challenges, a flat table challenge and a more challenging sequential challenge, will be asked to open source their approach so that it can also be assessed for generalizability, creativity, and other elements. And all of that will be published, including also the holdout data set to calculate everything yourself. Currently, the holdout data set is kept under wraps so that we have a fair competition.
Yeah, makes a lot of sense. Alexandra, we'd be remiss if we didn't mention that there's nothing like rolling up your sleeves and doing it yourself. There's a synthetic data SDK for most AI. I think you can run that on your platform, on the cloud, or locally.
Absolutely. It can basically run everywhere. So that's also one of the benefits. We didn't go into details of synthetic data generation mechanisms. And currently we see a lot of experimentation going on with diffusion models and also with large language models. But using these large language models for synthetic data generation is oftentimes just an overkill in contrast to this highly specialized synthetic data generators like our tabular argon. Plus, you also have the benefit that you don't incorporate the world knowledge that the LLM might have encountered, but only learn from the source data, which at least to date gives better data quality if you want to have a replica of your proprietary business data. To your point, it can run basically anywhere.
Yeah, that SDK is open source, right?
It is open source, yes.
Yeah, which is key. And I do think that looking at the prize, checking it out, encouraging our listeners to try it out as well, because one, there's a prize there, but also I think just the value of learning this, because it'll really help reinforce that accuracy versus privacy issue we're talking about, and understanding better privacy thresholds. I think my notes on the website here, you've got a couple of metrics in there, like distance to closest records and other accuracy.
Neighbor distance ratio is also there, and some accuracy metrics, yes.
Yeah, and I think that's pretty cool. I was just thinking to myself, if I was to do this, the flat data challenge is definitely, I think, very approachable. There's other open source tools out there that our audience may be familiar with. I think
Data Vault is they changed that 1 or 2 years ago. They started fully open source and then went to another license.
I think, tabular, because it is a tabular data set. So I think I can include some other links to.
Absolutely. I think we also have 1 or 2 open source tools listed there. As mentioned on the website, you can use whatever you want. You can build something from scratch. Important is just that later on, the submission needs to be open sourced if you aim to win the 50K per each challenge.
And I'll include some other open source tools in there. Yeah, Alexandra, how can people follow your work, keep in touch with what's going on with mostly AI?
Absolutely. So anybody interested in a deeper dive in synthetic data, both from a data science but also business perspective, I did this LinkedIn Learning course, which is available on LinkedIn Learning. But if they ping me, I can also get them a link to directly access it, following me on LinkedIn, or even better, passing me up at a conference. Since I mentioned to you earlier, I'm traveling quite heavily. All of these are good ways. And then mostly GitHub repo and the repo of the prize plus the SDK itself. There's also quite a nice comment section being populated. So this is another way, or just the hello@mostly.ai email address for any feedback on our smart imputation prize questions. Really happy to hear from the crowd.
Yeah, that's a good question. If people want to discuss the competition, exchange ideas, form teams, is there a form for that?
They can definitely form teams, and there's also some referral mechanism in there because I honestly need to look up the exact submissions. Every participant has 3 entries per week, but if you refer to other people and they use your link, you can boost your submissions and have even more goes at it. So all of that on the website. In terms of contact, yes, the discussion thread on GitHub is linked, so that's the best way to go about it. But the hello@mostly.ai email address, definitely a way to go if you have general feedback about the SDK or some questions.
Yeah, that's some good inside knowledge there around submissions with multiple team members. So that's a good tip. And then, I do see the discussion thread on GitHub is at the bottom of the Mostly AI Prize page. So it's mostly AIprize1word.com, and I'll post that in the show notes as well for our listeners.
Fantastic. I'm looking forward to your submission.
Yeah, I got to fit that in though. Fit that in.
Please do, next to all of the 5 different things you plan to juggle the next few weeks you mentioned.
This is how I learn as well. Roll up my sleeves, ready to go.
Participate.
But listen, Alexandra, that's a wrap for this conversation. Thank you so much for sharing your insights, not just on preserving privacy, but on how synthetic data can improve accuracy, model performance, fairness, and helping us understand the ethics behind this as well. And I think this is a great initiative around synthetic data, the Mostly AI Prize. So really excited the outcome of this conversation. So definitely share with ODSC who the winners are. Maybe, we'd love to do a blog and share with our audience how people tackle this problem, because the second challenge, especially the sequential data challenge, is quite advanced. I remember doing something like this when I was in a few of my finance gigs. And
that's true. Behavioral data is the new gold. One of the exciting areas of synthetic data to unlock these data assets in financial services, healthcare, mobility, and so many other fields. Thank you so much for having me. The rapid fire episode we did at the conference was great fun, but I thoroughly enjoyed having a more in-depth conversation with you. Many thanks for all the thoughtful questions.
Yeah, and thanks again, Alexandra. I'm sure we'll have you back to ODSC in the near future.
Yeah, absolutely.
Your engagement directly contributes to the growth and success of our community. Please subscribe now and don't miss out on the next enlightening episode. This episode is sponsored by ODSC West, the premier AI Builders Conference, celebrating its 10th year this October 28th to 30th in San Francisco and virtually. Learn more at odsc.com/California and use the code PODCAST for an exclusive 10% discount. Supporting our podcast by subscribing not only helps our small dedicated team at ODSC, but also unlocks exclusive benefits for you.